So I'll just let the recording get itself started. There we go. Right. So what we're covering today in the last of our 3 topics is following on from Sam's setting up Profinet last week, where we did switching, routing and firewalls. And now we're looking at actually hardening up the S7-1500 and what security we can put onto the S7-1500. So this is all part, as Ben is going to cover. So Ben Cayley from our cybersecurity team is actually going to present for the second part of today. And what we are going to be looking at is the defense in depth. So as we said, we've looked at this middle layer, the network security, putting in a firewall. But what happens if somebody manages to get past that firewall, or maybe it's an internal employee who is plugging in actually into the factory network? So it's looking at actually hardening up the 1500 and what we can do inside the 1500 to make it more cyber secure. There are various things we can do to it. So the first thing that we can actually do to it, we can actually put a lock on the door of the 1500. So there is a mechanism there for putting in a small lock onto the 1500, and what this does is it keeps the front flap of the 1500 shut, so somebody can't put the PLC into stop, can't change its state, can't remove the memory card out of the 1500. Everything is kept inside the 1500. And we can also disable the ports on the 1500. So if you have any Ethernet ports which are unused, we have the ability inside TIA Portal to actually turn those ports off. All of this I'm going to demonstrate. I'm just going to go through the slides first, and then I will go in and demonstrate how we do this. I won't be demonstrating the lock because I haven't got my webcam on, but it's just a mechanism on the flap which enables you to lock it shut. We're then going to look at password protection. So we can password protect engineering operations onto the 1500, whether somebody can come in and take remote control, view the web page and everything like that. That can all be, we can put access control on that. And we can even have access control for HMIs that want to connect into the 1500. So we will look how we set that up and the changes we can make, and also we can change this from the program as well. So we can decide whether we want these accesses to be allowable from the program, not just at engineering time. So we're going to go through that. We're going to look at if somebody does get into the 1500 as a further example of defense in depth. What you can then do is you can actually protect the individual code blocks inside your 1500. So you can do this. It's quite common that people who put a lot of effort into writing code blocks will protect the block anyway, but it can be part, again, of your defense in depth cybersecurity, that you can actually protect the code inside the PLC so that even if someone gets in, they can't make changes or they can't see how the program is operating. So we have the capability to protect the code inside the PLC. And we can also bind the code to the PLC. This can be bound both to the memory card or to the actual PLC. So if someone tries to copy the code, they can copy it. They may be able to copy it if they've got through all the layers of protection, but then they can't actually run that code because it is bound to a specific memory card or to a specific PLC. So it just means that code can't be copied and then used elsewhere. And then finally, what we're going to come on to is how do we communicate in a secure fashion. So this is passing data either up to a PLC, up to a PC, so maybe up into a factory system, so into a MES or an ERP, sort of factory management system, or even between PLCs. So we can do this as well in a secure fashion, and means that the data can't be changed, and also can be encrypted so that people can't read that data either. Only the intended recipients will get the data, and they can also see that it's come from the PLC they thought they were talking to. So let's go and have a look at some of the setups and how we actually achieve that inside the TIA. So all I've got here is I've put in a basic project, I've put in a PLC, there is no protection on here. So I'm just going to go through some of the mechanisms that we can use to protect. And probably the most important that probably most people don't do, being honest, is straight away into protection on here. We have the protection that we can set up. So this is enabling different levels of password access into the PLC. So by default, we would have full access, probably, and this is, I would guess, probably 90% of PLCs tend to have, when I look at them on customer sites, they're just left on full access. So anybody can go in, anybody can make changes, anyone can read the data, any HMI can connect to that data. By setting it up and moving it to no access, then the person has to know the different passwords to get to the different levels. So even a HMI, you have to go into the connection on the HMI and give the HMI the password that enables it to talk to this PLC. So this is probably one of the best defenses you can just put on a PLC to make it secure, is just implement this password protection into your PLC. It then makes sure that even if someone's inside the network, if they don't know the password, they still can't get to the PLC. I've got it set at no access. One of the features that no access does is it disables put-get communication, because put-get communication uses the standard S7 protocol, and because it uses that protocol, it basically opens up the PLC, and it means that anybody from outside, because it's a well-known protocol that has been implemented into a lot of other products, so it means anyone can put or get data out of that PLC. This means that they can just randomly write data in, assume that you've used data block 1 and start writing data into data block 1. And there is, if put-get is enabled, the PLC will just accept that data and overwrite anything that is in DB1. So one of the recommendations is that you disable put-get and you use one of the more secure forms of communication that I'm going to show you towards the end of my demo. But if you put it onto complete protection, by default, that is disabled anyway, and you're not allowed to turn it on. So it just takes away any possibility that put-get will be there. At the same time, if we're putting a password on the actual PLC, it makes sense to actually go to the display, and I will find it in here. The display here. So in the display, we can also put a password onto the display. So we can password protect the display, and this means that even if somebody comes to enable write access, and we can put a password so we can enable display detection protection there, and then we can type a password in here. And what that means is now, even if they go on the display, they have to know the password, so they can't do things like change the IP address of the PLC, write values into tags from the HMI, from the display. it will protect the display as well. It's just an added security feature. If, as I say, if you're putting a lock onto to stop the flap being open, it also makes sense to turn on the display. Any unused Ethernet ports, so if you want to stop somebody actually plugging in with a spare Ethernet to actually get on it, if you simply select the Ethernet port, you come onto here. So say we're only using port 1 of these two, I can select the second Ethernet port, port options, I can turn off that Ethernet port. So that just means now if someone wanted to connect into that PLC and there are no spare Ethernet ports because we've turned them off, they're going to have to pull out a running part of the system, which will probably stop the machine. So it just it means that somebody can't sort of plug in and monitor what's going on while the machine's running by turning them off. So it's just general advice. If you want to try and harden up your 1500, this is one of the ways we can do it, by just turning off the port. One of the really nice facilities on a 1500 is, and the 1200, as an onboard web server. You have to realize that by turning on the web server, you actually do decrease the level of security, because obviously it's another place that people can get into a 1500. But what we can do is we can activate the web server, which it will do here. So it does slightly decrease the level of protection on the 1500, but then we can make this web server as secure as possible. So what we can do is we can permit access only via HTTPS. So this means that it is a secure connection from our web browser onto the 1500, so data can't be changed while it's traveling from the 1500 to the web page. We can set up users. So at the moment, by default, it's set up for everybody as a minimum. Minimum basically means you can get onto the front page of the web server. And then what most people do, again being honest, is they go through and they tick like this, and they go, right, that just means anybody who now logs on to my 1500 can do anything they want. Again, not recommended. What we would recommend is that you put a user in, and when we go into my other project, you'll see that I've set one up as an admin, as a diagnostic user. So this enables him to go in, or the user to go in. He can query the diagnostics. He can look at everything like I might enable him to read tags, but he can't actually write tags. He can read watch tables, but he can't write to watch tables. And I don't allow him anything where he's going to be actually able to write down onto my 1500. So it just makes the web page as secure as it can be. So if I tick that, put the password in. That would enable that user then to log in, and we'll see an example of that when I go to my made-up system. So that is the sort of like hardware setup of a PLC, and hardening it up, where we've set up password to get into the PLC. We've set a password onto the display. We've disabled any Ethernet ports that we're not using, and we've set up the web server so that it is allowed, but it's in a secure fashion. So what we're now going to look at is actually program code. So if you want to further protect, because you've either got a lot of intellectual property inside one of these blocks, or you just want to make it so even if somebody knows the password, they've got into the 1500, they've then got to go a stage further to actually look at the program code. And this is very easy. All we do is we go in and we can select know-how protection, and then what it asks it for is a password that we put in, to enable know-how protection. And that block now gets compiled up, and then it has a little lock symbol on it there. So that block now, if I want to open that block in the future, I need to know that password. So it's one thing that it will pick up from what I'm going through here is that it is important that you have a password strategy, and you probably use something like a password manager to store these passwords for you, because there is no backdoor to these passwords. So if you lose this password, then it is not possible to get back into that block. So just be warned. I will recommend that you use a password manager or something like that to keep a track of these passwords, because we do not have a way of getting back into that block if we lose the password. A further thing that we can do to our block, if we right click and go into properties, what we can then do is under protection, we can put on binding. So this is where we bind that block to either the serial number of the memory card, or we bind to the serial number of the CPU. Okay, so if I say I want to bind that, I've not compiled it, it's probably because there's no code in it. If I compile a block, no, it's because I haven't put any code in it. But if you just go with this option here, when I go to download that that block into the PLC, it will automatically take the memory card number. So you don't have to. If you have the PLC available and you have the memory card there, you can just say on this download, bind it to that card. That means if the person comes along and then does an uplift out of the PLC, it will have that binding to the memory card. If you actually want to protect it in the project, what you would do is you would enter the serial number here. So you would read the serial number off the memory card. You would bind it to that, and then you would know how to protect that block so that they couldn't then get into the properties of that block to be able to change that serial number. So it just depends. If you've got the hardware available, you're just doing a download and you don't want people to be able to uplift it, program out the 1500 and run it on another PLC, then this is the option for you. If you haven't got the actual hardware, but you've got the memory card number, you can put that there. Again, put on the know how protect to stop somebody being able to go in and look at that or change it. So that's binding and looking at all of the use. As you've seen, I've been putting in passwords and I've been changing my project, and everything that I've been doing so far is to protect the actual PLC and code while it's in the PLC and while it's being used. But we have also got this project, and what we can do, there is an inbuilt mechanism to actually protect the project and give people different rights while they're using the project. It's also necessary to use this for setting up communications and OPC, and so the certificates that we use to ensure that our communication is done in a secure way. So there is a setting down here inside TIA called security setting. If we go into that setting and we click this button, it now asks us to create a user and a password. The user I use for myself because I do a lot of this sort of protection. I use a standard user. So inside my projects, I know that if I have a protected project, that I know one of my standard usernames. That means that I can get in to the project, because again, this cannot be undone. Once you've protected a project, you cannot then remove that protection from the project. So to now get into this project, once I press save and exit, then I would have to know that username and password to get into the project. Now we've actually created that. I've created my standard user. Inside here, we have some pre-built standard users that have been set up. We can actually go and have a look at this standard user. So we have an engineering administrator, and what we allow him to do is we allow a administrator, he can open the project with read write. We might create a diagnostic engineer, because the engineer can still open a project with read write. So we might want to have a maintenance. This is where I give away I can't spell. But so we might go with a maintenance person, and we're going to say that they can actually only open this project with read write. So that means that the said I can't spell. So that means that this user can now open up this project. He will, if they're assigned to the maintenance role, they can open the project, but they can't actually make program changes. So they can't change the program. They can still download the program into a PLC, but they can't actually edit the program. So this is really good if you've got any validated code or safety code. So you can give the project, and as somebody who logs in as a maintenance role can only sort of like go online, diagnose any faults, but you can't actually change the program. You could, as I say, you can re-download it, but you can't change it. Great for validated and safety code. So once we've built that user, that role, we can now create a new user. So we're going to add a standalone project user, because this can be connected to a Windows domain server, but at this point, I'm just going to do it as a project. So again, this person now has these red boxes. Does this drive anybody else mad? It would help if I could type. And I haven't got an uppercase character. It's one way of filling the time up. Not type passwords incorrectly. There we go. So I now take that user and I assign him to the maintenance role. So that means now that even on my programmer, when I open the project, I will be now given the maintenance, and I log in as my maintenance engineer. I enter the password, and then that will only allow me to do what is defined by the maintenance role, which, as we've already seen, is it gives me read-only access into the project. So what we've also got in here is if we have got something set up, so if we have a CP card, which is an inbuilt firewall, we can actually set up the firewall, which is direct onto the PLC. So that's what Andy was going through, but he had a separate firewall. We can build the firewall onto this PLC. We can set up VPN, so we can set up a VPN again through the CP. We can set up a time server on here as well. So, and we have a certificate management, which is what I'm going to come on to now. So, what I'm going to do is actually flick into my running project that I've already got set up here. And inside my running project, I have got a open PLC. So this hasn't got security on. And then I've got a secure PLC. So if we just quickly come onto the PLC, what we will see is under protection, I've got my access levels set up. I've set up my web page. So if I want to go online to that PLC, I say I want to go online. And of course, I've got my old password in, so I'm just disabling my password. Love it when demos go right. Why is it not asking me for the password? Anyway, we will come back. So it is, it should have asked me for the password. I've obviously pre-built this and put the password in. I'll tell you what we will do. Let's close that down. Let's show it fully. So when I open up TIA, that's a protected project. So once it opens up, what we will see when I go to open that project, what have I done here? Yeah. Gives me a heart attack. So it asked me for my login. Because it's a protected project. It will now let me into the project. If I go into devices and networks, if I click in that, and ask to go online. It's now asking me for my password to go online. So it's a fully protected project. Once we're online, it now, if I go offline, and then I ask to go online again, it will just take me straight online, which was the problem that I had before. It wasn't timing out. So that's just to show you that if you put this protection on, you don't, it's not a constant entry. I've entered my password once to actually come into the project, and then I've entered my password once to go online to the PLC. Security always makes things slightly less easy than if there's no security, but we're getting all the benefits of protection if someone, is trying to cyber attack into a PLC. What I have set up, as you've seen, it's a protected project. So in my security settings, I have got some users. I have got a specific user, so I've built a user, which is OPC user 1, and this OPC user has the assigned rights that in runtime, so it doesn't have any impact on engineering, but in runtime they are allowed access into OPC clients and servers. So they have server and client access on both PLCs. So this is a really simple way, without having to remember actually users and passwords everywhere. You can put one user in and you can assign them rights across your projects. Because what we're going to look at now, if I go offline to here, is how we can do communications in a secure fashion between a separate piece of plant, so a factory system, maybe another SCADA or a MES or something like that, down onto a 1500 if we've turned off put get, because this is in no access. So the mechanism that we're going to use is OPC UA. So we're going to set this project, this PLC here, as an OPC UA server, but we're going to make it secure so that people can't just browse onto it with any client. So what I've done is I've activated the OPC UA server on this device. I have turned off the standard interface, and I will show you this when we browse into this PLC. So by default, this standard interface is turned on, and by leaving the standard interface turned on, what you in effect do is open up all the data inside the 1500 to your OPC UA client. It can go in, it can look at all your inputs, all your outputs, all your data blocks, if that's what you've set up. So the recommendation is that by default you turn that off, and then you build a separate server interface, which I'm just going to briefly show you how to do that. I have left it all at standard default rates. It has created its own certificate. So it's created a certificate for the server. I have turned off all but the highest level of encryption and signing of the OPC server. So I've removed any no security and lower levels of access. I've actually put in, my external application has its own certificate that I have imported into the PLC. So by importing this, I've said that this is a trusted application that I trust to come and read my data. So that has come out of the OPC client application. That again could be SCADA, could be your MES, could be your IT supply you with that certificate. You put it onto the PLC. I've disabled that I'll accept any other client certificates, so it's only looking at that client certificate. And I've said to come in and use me, you have to have a username and a password. So there are 2 users and passwords. So I've set up another one here called admin, but because up at the top, I've also said enable user rights by the project settings. I've got that OPC user 1. So because I've set all that up, if we now go to my client application, I open up my client. If I go first of all to my unprotected PLC, what you can see here is the one that I've done no security. I can simply select none. It connects into the PLC. I tell it to go online. It's gone straight online to the PLC. I can go into the PLC. I can go into global data blocks. I can get all the data. I can go into instance data blocks. I can go to all the data. I don't think I've actually got any inputs set up, but if I did, I could go to inputs. I can go to the memory area of my PLC. I can bring that down, just bring it in because there's no protection on this. I can turn it on and I can write data into my PLC. So leaving it with the standard interface and no security, it has really opened up that 1500 to the OPC. It's nice and easy to get stuff in and out, but it has made it very open. In certain ways, it's actually worse than put get, because with put get, you at least have to guess where you're putting the data or getting the data. With OPC UA, without any security, it is, you can actually browse the PLC and you can actually see what is inside the PLC and what you want to read and write to. If we now go to the secure one, so we go to our 013, you'll see it only offers me, so it doesn't offer me the no security, it only offering me the sign-in encrypted, just because I've connected to it in different ways. I now go that I want to connect to it, so it's now asking me for a username, so we'll put in OPC user 1. So it's allowed me in, and now when I go to PLC 2, there aren't all those data blocks. The only data blocks I get, the only data I get to is what's called the server interface. So this is predefined data. So I can bring that data and bring it in and put it in there, and now I am reading data out of my secure device. I will say that for me to connect onto it, I have had to give it the server certificate of here, and this client has also got the server certificate from the PLC inbuilt into it to say that this is it's a recognized PLC that it will connect down onto. So this is fully secure. It's also encrypted, so that nobody can actually read that data as it's being transferred between the two PLCs. So how did I build this interface rather than, as I go in here, giving all the data available? So if I go into my project, what I do is actually inside my PLC, we've got our PLC here, OPC connections. If I open up my server interface, I have built an OPC server interface, and it's simply a matter of going into my program where all my tags are available. So I can say data exchange, there'll be a tag in here. So I've got that tag. If I want that to appear in my OPC, it's a simple drag and drop it in there, download that into the PLC, and that then enables that to appear into our server interface here once it's been downloaded. So I can control from my PLC project exactly what is allowed. I can also control whether I want that data to be read only, write only, or read write. So I have full control from my PLC program over what data is accessible and what people are allowed to do to it from the from within the OPC server setup. Again, we can use this as well. So what I have actually got set up for inter-PLC communication. So if I go to my other PLC, so my open one, so even though it's open in itself, it can still communicate with a fully secure 1500. And what I've done here is I've set up a client. So on my client of my open 1500, I've said I want to read data. This is set up in a very similar way. We can go online access. So I want to go to 192.168. So the setup, I've used the wrong certificate here, but if I had picked the right certificate, it would have connected on, and then what it would have allowed me to do is just drag and drop values out of the setup. And then also inside here, I have actually set my security up. So what you can see, I've set the same security OPC user 1. I don't need to know the password because the OPC user password is set up through the entire project. So as long as I put in OPC user 1, it will allow me to connect. So it's the same setup here that I made in my unified automation, my client project. Once you've set that up, you can then pass data in a secure fashion from PLC 2 to PLC 1. So that's using OPC. The disadvantage of OPC, it is very, very secure, as you've seen. However, there is one disadvantage that most people see. If you want to use OPC, it is a licensed option onto the 1500. So you do have to purchase a license for each of the PLCs, which are either acting as a server or a client. So people also want to pass data between PLCs in a certified fashion, but they don't want to use OPC and they don't want to use put-get because that's insecure. So we do have a second method of passing data between PLCs, and it's called Open User Communication. So Open User Communication now allows you to set up a secure connection between 2 or more Siemens PLCs, and it's all done inside TIA and it's all integrated in. So for this, we have to have a protected project to enable us to do this secure communication, because to fully make it secure, we have to use certificates in each of the devices. So, and we only get access to our certificate manager if we protect the project. So what I have actually done is I've set up my certificates. So where do we set up the certificates? If we go into our project and we go into the configuration, and what you will see in here is on each of the PLCs, we have a certificate manager. I can click in and I can add a new certificate. So as part of every TIA portal project, it comes with its own certificate authority. I'm not going to go deep dive on what particular certificate authorities and everything through this, because that's probably an hour in itself. And this is just an overview. We can run a further session if you want me to fully go through certificates. However, I am going to create a certificate based on this project's certificate authority. And all I'm going to do is you can create a OPC client and server, which is what I created for my other. I can create a web server certificate, and I can create what we call a TLS certificate, and this is the one that we use to do the communication between the different PLCs. So what you will notice, I'm going to cancel that because I don't want to create a new certificate. But if we go back into our certificate, global certificate manager, what you can see here is they've all got a number on them. So we have used number 2 as our certificate authority. And then on our devices, I have got a number 3 and a number 4, where these are, one of them is the Open User Certificate for PLC 1, and 4 is the certificate for PLC 2 for Open User Comms. We then use the standard Open User Communication block. So anybody who has done Open User Comms, it is a standard block that we have, which is a send and a receive. We have a send one end. This is the receive end. So we can see here that we have our block. On the receive end, you simply say that you want to enable it to receive and you want to connect. So this is all you have to do on the receive end. You then have a data block where you store the connection details and the actual data that is being transferred. So if I go into this data block, if you were doing standard open user comms, you would just use a format of data which is TCON IPv4. Because we want to do all this securely, we are using the secure form. So this is a pre-built, you type that in and it automatically brings you this down. These are the standard parameters. So this is where I am putting in the IP address of the PLC that I want to talk to. So it's very simple. We can, as I say, we can run a seminar and we have already run a tech talks on setting this up. However, today what we're looking at is the secure form. So what I've said is it's got these additional bits of data. It has got that we want to use secure communication. And in this particular PLC, number 4 is my certificate, which when we were in the certificate manager, you saw number 4. And we are using the certificate authority number 2. This certificate was created from this certificate. So you just put 4 and 2. If I go to the other end of the communication, if I go into my secure open user comms and I look at the data block, and what you can see in here is that I'm using the same certificate authority, which is number 2, and I'm using the certificate in this PLC as number 3. So those came out of the certificate manager. You just go in there, you create your TSL certificate, it gives it a number, and this is the order that you put them in, and that then forms up that communication. So what we will see, if I actually go online, again, this is an insecure PLC, so it didn't ask me for it, but you can see that this is just communicating away now it's just going as fast as it can, and it's just sending data from this PLC. The data it's sending is in our data block, so it will be, I think I'm only sending 1 byte, so I'm sending a couple of bytes of information here from this PLC over to the other PLC. So it's simply doing a T-send straight over to the other PLC, but this is a fully secured connection. The 2 PLCs recognize each other. They've got the certificate set up, and say that the data cannot be changed between the PLC. So the data that leaves here is the data that arrives at the other PLC, and you can't send it from a third PLC and pretend to be this PLC, because all the certificates and everything are set up. So the one thing that I forgot to show you while we were there, we've also got our web page. So I do have, so if I go for HTTPS, so I'm only allowed to connect in a, I set it up so the web page would only allow HTTPS. So you can see we get our little lock symbol here. So this is telling us that we're on a secure website, so we know we are on the real website. We know that nobody can read any data that we put in. Because I haven't yet logged in, it's not letting me log in. So the user that I had was a diagnostic, the diagnostic user, so I put that in as a user of diag. Type the password in, and now it gives me the capabilities that I've allowed for that user. So I can go into my diagnostic buffer. You can see that inside the diagnostic buffer, we now also get security information inside our diagnostic buffer. So it's given me the people that, you know, if somebody has tried to get in to the web server, you're getting that log on. You will also get told if somebody has tried to get in to the PLC but has failed. So someone's put the incorrect username, or so here we have log on denied because I've put in the wrong password. So you can actually see if people are getting in. Because that could be quite repetitive, you can also actually set that up and group them together. So I've set it up so it will group all the occurrences every 20 seconds. You can set that to a minute or an hour. So instead of hundreds, if someone is trying to repetitively attack the PLC, you could end up with just loads of log-on failures here. So you can just say, just group them up for me for the last hour, and then you would get the number of attempts that have happened in the last hour to try and log on to the PLC, just to try and keep the clutter. So here, I've got certain views, I've got certain capabilities. I have created a higher level user who is an engineer, and then I put the password in for him. And now I get the full capability. So I've now set this up so I can go on browse files, read and write files. So you can set up different capabilities on the web browser just by the username, just to further protect it. And the final thing that I'm now going to show is how we can actually set this up so that only if there is a, say, a physical action on an external connection. So let me just go offline to PLC 1. So at the moment, we've got PLC 2. I can go online because I've already put my username in. So you can see here that I've got online. I can go into my program blocks. I have got in here, I have got a bit of code. So what I have got is a, let's go online to that. So this is a standard RFID switch that we have. So it's a key switch which is driven by RFID. So I have to put an RFID key into the key switch. So it's a little RFID chip. And then I'm allowed to turn the key switch to one of 4 positions, depending on the authority of the key switch. So what we can see here, this is an authority level of 19. It's a very high authority, so that I can actually move that to any one of the 4 positions, and it will turn on the key switch to the authority level it's been allowed. I've then used this inbuilt block here, which is end this password. It's a standard block. And what I can now do is I can enable, depending on where that key switch is positioned, I can enable or disable the password. So you've seen I've typed my password in that allows me to have read-write access into this system. So if I go offline now, and if I move that key switch or remove the RFID, if I now try to go back online, it's now asking me for the password. If I put in the password that I know should be good, it's now telling me, because the key switch is not in the correct position, it's now telling me that the key password is currently invalid on the device. So this means that remotely now, I cannot get onto that PLC. I have been locked out of that PLC. If somebody physically at the PLC or via a HMI has to allow me to get onto that PLC. We can set this up so that I can allow, let's say I can allow read-only access on. So at the moment, you'll have to believe me because you won't see the password I'm typing in. But what I'm going to do is I'm going to type in the read-only password. So it's let me put in the read-only, so I can now go on and do diagnostics. If I was now going to make a change on there, and I said I wanted to download that, it will compile because that's been done offline. But now it wants the password because that was a read-only password that I gave it. So it's not going to allow me to download. And again, that has been enabled, even that read-only password has been enabled by the position that the key switch is in. So what I need to do is I will move my key switch to the correct position. I will now enter the it's because I've changed the password halfway through. So let's just go offline. Now go download. So it's asking me for my read write, and you can see now because I've entered the read write password, it will enable me to do that download. I can now go online like that because at the moment I am connected for read write access. If I remove my RFID key, so I walk away from the project and I remove my RFID key, it automatically knocks me offline. So I can't now, anybody coming up to a laptop can't now make a change to that PLC or download it. So it's a standard block. It's just inside our standard instruction set under program control, runtime, end this there. So it's just a way that you can further enhance the security on the 1500 by actually, I've done it with an RFID key. That could be a physical key switch on the outside of the panel. So again, you could use this to allow, if you've got remote access onto your site, but you don't want somebody just being able to dial in and then make changes on the PLC without your knowledge, you could have a key switch on the PLC that will block all the passwords until you put the key switch into a program position to allow somebody to make a change onto the PLC. So it's just a block that is further there to enhance it. So with that, I'm going to finish my part of the demo. I'm just going to hand over to Ben now just to go through some of the other security services that we can offer.
Dave, just quickly, there's no comment ability on here, so is it worth just, has anyone got any questions at this point before we move across? Or maybe everyone's shy because of the fact we're recording.
Yeah, I've got a quick question. Obviously, we've been going through the 1500 PLC and hardening. Is there options on the S7-1500 for similar hardening functions and security?
So we do have password protection. We don't have the levels of password protection that we have on a 1500. So we can basically allow access or not allow access from the program. But there are, I would have to check out, I will be honest with you, I don't know whether we can, I know we haven't got the OPC server because that's not a something that is available on a 400. I would have to check out the open user communication to see whether we could do that securely on a 400. I think you may have to fit a CP card to get that level of functionality. So we have a lower level of security on a 400 and a 300 because we don't have the ability, as I say, to come up with the levels that we've got. This password protection block, there is that available for the 300 and 400, so you can change it from within inside the program. But as again, I can take that and I'll come back to you.
Yeah, it'd be interesting to know what the level of security is available on the 400.
All right, I will take that as a question and I will come back to you.
Yeah, the only other additional one, I'm working on a project at the moment and the customer has, they may not know what they're talking about, but specifically asked for HMI hardening. So are there options, like you've shown us through the PLC there, are there options to block ports and enable security on the HMI?
What there are on a HMI, this was specifically aimed at 1500. But,
yeah, of course.
And I'll tell you what, I'll pass back to Ben unless there's any other questions, and then right at the end, if you just hang on, I will show you explicitly what we can do with the HMI, and anybody else who's interested can call.
Okay, yeah, that'd be great. Thank you.
All right.
Yeah, thank you very much.
All right. Any other questions, or I'll hand over to Ben?
Hi there, it's Kieran O'Toole here. Can you hear me?
Yeah. Yeah.
Oh, brilliant. Yeah. All I wanted to check was with the PLC hardening and any other hardening, is there any way of linking the password side to the Active Directory accounts? So
right. Yeah. If you noticed when I went in to, I haven't got an Active Directory. So, but if I go into my users and roles here and I go to add a new user, we do have this option, which is add user from UMC. Okay. So the UMC is an add-on to TIA, and that is user management control. So user management control will actually link the TIA into the domain server. So all the passwords and users and roles can be set up from a domain server. Now, I haven't got full detail because we haven't seen it yet, but I have been told that this is going to be further enhanced in V17 to then be able to set up some of the usernames and passwords and access levels that I've been showing you today. You'll also be able to use the UMC, so the user management control, to set those up to link those into a domain server as well as part of the V17 update. But I can't fully commit to that because I haven't seen it.
So then at the moment, that's brilliant to hear, by the way, but so then at the moment, as far as having single username and password that's consistent across whatever applications are being used, is it that we could take the Active Directory and link it in through UMC and use that for the permissions then right the way down to the PLC hardening? So you're referring to, for God's sakes, don't forget your password.
That all sort of disappears. That disappears at that once. If you want to, you can do it all through UMC, which we can do at the engineering level. So all this, the setup of the getting in to the project. So when you open the project, if you were logged into your Windows PC with your Windows username, it will actually automatically open that project if you're logged in correctly, because it would recognize you as a Windows user. As you're the user, you have an access into that project. So all of that level goes away. You can see here that we create the OPC UA user name and password. That could all be connected up onto the UMC as well, because I've set them up through this tool. But some of the password protection onto blocks and things at the moment, that isn't part of this. We're putting in different users and names, and the access control into the PLC isn't through this at the moment. As I say, I have been told that that there are definitely further enhancements of this in V17, and that the UMC part of it will be pushed further into the PLC, so that yes, my warnings about don't forget passwords, don't forget users, sort of like will become just part of the Windows logon process.
Okay, thanks. That was really thorough answer. Appreciate
Okay.
it.
Anything else? Or I'll hand over to Ben. I've been trying to hand over to Ben for 5 minutes. Go on.
Just one quick one.
Yeah.
You said when you set your maintenance guy up, you said he could download programs, but he couldn't change programs.
Yeah.
Would it stop him from downloading a different version of an FC?
I'll have to check that. That's a very good question. I will check it while Ben's on.
Obviously, in theory, if he could download a modified version, then
I don't. Yeah, I will check.
thank you.
When I say download, yeah. I'll do a check and I'll come back to you. Is that all right?
Yep, that's great. Thank you.
All right, I'll hand it. Ben, you're finally up.
All right, we're good to go. Thanks, Dave. Could you just stop sharing your screen then for me? Thank you. So, morning everyone. I'm Ben Cayley. So thanks for the introduction, Dave, and thanks for the really thorough look at some of the really practical concepts and the features of how we can implement security on the 1500. What I want to spend the next few minutes doing is kind of taking a step back and looking at the bigger picture of security. So come back to a couple of the concepts that Dave's already given us a lot of detail on, but I also really want to highlight that when it comes to security, technology is not all of the answer, and there's some other considerations that we've got to take into account. And also really highlight that everybody involved in an industrial control system throughout that whole supply chain has a responsibility when it comes to security. So I'm the business development manager for our industrial security services business, and we're a part of Siemens that have a team of security experts basically who are able to help with a number of these concepts. So I'll also take you through some of what we tend to spend our time doing, helping customers on some of these security areas. Give me a shout if you can't see my screen, but hopefully that's starting to come through now.
Yeah.
So I wanted to start off by coming back to the very first slide that Dave showed, and this is around our defense in depth concept. So this idea of defense in depth is something that's really ingrained into how we deal with security across all of Siemens. So we use this concept when we're protecting our own factories, places like Congleton, if any of you have gone to see there, but really across the whole globe, we protect our factories using this concept. We also integrate defense in depth into the way that we design our products, both the way that we kind of go through our product lifecycle management and actually the process of designing and manufacturing them, but also the features that we build in. And that's really what we've been hearing about this morning up until now. So the basic idea of this defense in depth concept is that what we're looking to do is have multiple independent levels of security on your plant. So the way that we've structured it here that you can see is with 3 main layers. So what we're saying is you need security in all 3 of these layers to make sure that you've got security of your plant overall. And what we've been looking at today is really been focusing on the system integrity with what Dave's been showing us. So in particular, we've been looking at aspects of system hardening and also how you can use authentication, coming back to the idea of passwords and active directories, etc. That's a really good point to be picking out on this system integrity level. But what we want to be highlighting here is that there are lots of other topics to be considering. So things like patch management, for example, both of your PLC firmware, but also of any PC-based systems you might have down in that OT layer. That's something that we look at the system integrity level. Also, how are we detecting attacks? So are we really understanding if somebody's getting into your system and what they may be doing to make changes or potentially deploy some sort of threat? These are all the types of topics we look down at this system integrity level. Next one up, where we look at network security, that the sessions that have been happening over the last couple of weeks will have covered a lot of these topics, but here we're looking at things like implementing firewalls, VPNs, also how we can build network architectures up to ensure security from the get-go, really. And then finally, maybe something which hasn't been focused on this series so much up until now is around the plant security. It's still a really important topic. So here we look at things like physical access protection of your site. Dave gave a couple of examples of how you could use physical keys to lock out different functionality of the PLC, but we also look at how you can physically lock cabinets in the first place, how you can physically lock access to a particular control room or even to the site itself. All these kind of topics come under the topic of cybersecurity as well. We also look at things like processes and guidelines at this level of plant security, and I'll come back onto those in a second, really highlighting that fact again that technology is not 100% of the answer when it comes to security. And finally, we also look at the overall security monitoring of the system, so pulling data out of all of those different aspects of the system to understand what's going on. So really what we're trying to say here is that there are a lot of different considerations to take when you look at building up this defense in depth concept, but really it comes down to having those independent levels of security. So this is quite a nice way of kind of visualizing it and getting your head around the basic concept. What we're trying to do is move away from this idea of having one single layer of defense. So this could be air gapping a system, for example. We talk to a lot of customers where that's their kind of default position when it comes to security and this single layer of defense. It could be installing a single firewall, for example. But whatever that single layer of defense might be, the issue is that once you've overcome it, you're into that central part of your OT system and you're able to potentially deploy those threats. So that's where we have potential issues. What we're looking to move towards is a system where we've got, again, these independent levels of security, so that if somebody gets past your external defense, you've still got multiple other hoops to jump through to be able to get to the part of the system that you're aiming for. This is really, really going to deter those attackers. So I also wanted to address the fact of why listen to us, why take on this idea of defense in depth, and I really wanted to explain where the ideas come from in the first place, really. So this defense in depth concept that Siemens has put together is directly based on an international security standard. So you may have come across it before, and if you haven't, it might be something that's worth spending a little bit of time looking into if you're interested in the security topic, and this is the IEC 62443 standard. So this is an international IEC standard, and it's specifically focused on OT security. So there are lots of standards out there that look at the IT side of security. The great thing about 62443 is it makes it really practical for operational technology and manufacturing and process plants. So in particular in the UK, one of the reasons that the 62443 standard may be relevant to you and may be worth looking into is that it's a standard which directly aligns with the obligations of CNI operators, so critical national infrastructure operators in the UK have obligations when it comes to the cybersecurity of their plants through something called the NIST directive. So some of you may be involved in that through either your own work or your customers. And the 62443 standard is really the bedrock of what all this is based around. Same is true for guidance coming from the NCSC, the National Cybersecurity Centre. So that's part of GCHQ, it's part of the UK government, and it's the body that looks after cybersecurity. They have a focus on OT security, as well as all the other things you'd expect around banking and kind of personal devices. And when it comes to OT security, this standard is the one that they point people towards and base all their advice on. So as a result of that, we've heavily based our defense in depth concept on the 62443 standard. So if you align with one, you align with the other. And there's a couple of a couple of really nice aspects of the standard which I wanted to pick out here and just explain to you briefly. So the first of these is that the 62443 makes it really clear how security is something which all of the different stakeholders within a control system have to take consideration of. So you can see on the left hand side here, it's split into three main areas, starting off with the product supplier at the moment at the bottom. This is what we've been looking at this morning, in particular around the security capabilities of the product. So this is about giving the products with those security features built in the building blocks, if you like, of the system. So in this case, Siemens is your product supplier, and we've been seeing this morning that we've been building these security capabilities into our products. Something that maybe hasn't been touched on, but we could definitely talk about for a really long time as well. Maybe it's something we could look at in a further session if people are interested, is also that development process. So this is how a product supplier like Siemens goes through that process of designing and building their products. Security's also got to be taken into account down here, and at Siemens we've gone to a lot of effort to make sure that this process has been certified to the 62443 standard. So external bodies have come in and investigated the way that we do things and given us the relevant certificates to say that we comply with the standard, which is really great. The next level up is where I'm sure some of the people on the call today will sit, at the system integrator level. So here there's responsibilities around building a secure solution. So this will be taking some of the concepts which Dave's been explaining, taking the concepts that you'll have heard on the previous calls around network design and building a secure solution. There's also responsibilities at this system integrator level around your policies and procedures. So how do you deal with security as a company and during your development and design phases? And then finally, you've got the asset owner at the top. And again, I'm sure we've got people that fall into this category on the call. So here, what we're trying to highlight is that there's also an onus on security when it comes to the asset owner, when it comes to operating and maintaining your plant. So again, the policies and procedures here are really important. And it's only by all these three groups working together that you're going to achieve this defense in depth idea. So that was the first thing I wanted to point out, the fact that there are these three groups of people that all have to work together and all have to take their responsibility for security really seriously. The second thing is this idea that you can't just throw technology at the problem when it comes to security. And you'll notice here that policies and procedures have come out quite a few times in what I've been talking about. So a nice way to look at this is to kind of summarize the three main aspects that make up a secure solution and a secure security program. So the technology is one part. Yes, it's really important. We've been seeing from Dave how you can implement some of these concepts, and you need that technology to be able to create a secure solution. Equally important are your processes around the way that your company and your design process as well is governed around security, but also your people and the training of, from the end user's point of view, the operators on the factory floor, the engineers who have access to the OT equipment, but also everybody else that's within your organization and could potentially have an impact on the security of that system. So it's only by having all three aspects here working together and equally strong that you're going to have that overall security. So I realise what we've shown you up until now had quite a lot of information on the slides, but really this is what it boils down to. You need all three sides of this triangle for your overall security to be effective. So we wanted to explain to you how we're trying to make this easier for people to implement, because we realise that security is a topic that's been around for a while, but as we're starting to discover, there's a lot of aspects to it and that there's a lot to take on. So we wanted to show you how Siemens are trying to make this as easy as possible. So we make this defense in depth concept real in two main ways. So the first one is all about building security into those products. And that's what we've been hearing from Dave this morning. But on the flip side, we also have a team, which I'm part of, which is there to really support customers on this topic of security. And we're there for a few different reasons. One of them is that while the kind of new features which Dave's been talking us through this morning are fantastic, and you'll see that more and more of our automation portfolio has a focus on security when new features are released, we realise that an awful lot of our customers out there are working with legacy systems. People are working with kit which maybe doesn't have all of these latest features, but you've still got to be able to protect them. You've still got to be able to integrate them with higher levels of your network, get data out, remote access, all of these topics, but do that in a secure way with these older systems. So we've got a lot of experience in implementing that and really helping people to secure whatever it is that they've currently got installed. Another thing that we help people with are around these policies and procedures. So coming back to that triangle, we find that a lot of our customers feel quite confident in that top technology area because that's really where their expertise lie. But when it comes to implementing security policies and procedures, the softer side of security, if you like, maybe a little bit of support could be required there, and that's something we're able to help with. And finally, we help people in actually implementing some of these concepts, which Dave's been showing this morning and you've been hearing about over the last couple of weeks. So here, it's all about choosing the right features for the right project. So as Dave mentioned, in some cases, these security features maybe add to the engineering effort, or they maybe make it slightly more difficult for the people on the shop floor to kind of do their day-to-day job. And you've got to make the you've got to weigh up the advantages and the risks of implementing these features sometimes. So we spend a lot of time doing risk assessments with customers and really understanding what level of security they should be aiming for, and therefore how much investment and how much effort it's worth going into to reach that level of security. So that's what we're all about, and I'll just spend a minute or two explaining how we go about doing that. So within our security services portfolio, we split it up into three main areas. So first one is all around consulting, and this is about understanding what the current status is of an industrial environment. So we spend a lot of time here doing security assessments of existing plants and also assessing designs of greenfield sites. So this is really about understanding what the potential risks are with that automation system as it stands. We then take the information which is learnt in this consulting phase and take that into the next phase of implementation. And this is about plugging those gaps which may have been found and mitigating those risks. So here we're looking at implementing technology like firewalls, like endpoint protection on PCs, and starting to put a management structure into place to, as I said, plug some of those risks. And then finally, we move on to what we call here optimization, but it's really about the ongoing management of security. So what we're saying here is that security is not something which can just be treated as a one-off project or implemented once and then forgotten about. You really need to keep on top of that security posture long term, and that's where this optimization piece comes in. So I realise we've got about 5 minutes left of the call. Hopefully that gives you a brief overview of how we approach security as an overall company at Siemens, that wider piece around the policies and procedures and responsibilities as well. If anyone's got any questions on any of the topics that we've brought up, then please let us know. I'm happy to stick around for a little bit longer, but or take any questions offline. But I think I'll pass back to Dave at this point just to wrap up.
Yeah, thank you. So just to show, we're not going to cover it during this session. We can do another session. However, I will put it into the chat. We do have here a full FAQ and documentation on the security guidelines for the HMI devices, for both the standard one that we offer and for unified. So if you open that document up, it does go through again, setting up the signing of the image, transferring user administration, data exchange between the HMI panel and the controller. So it also talks about the APC UA, and it talks about the user management control as well, which was the where we are leading in, that is already available in Portal and will only be further enhanced. So I will quickly put that into the chat for you, so that people can get to that. Well, that's gone into the chat. I've also just popped into, which one am I in? This one. So I've set up a maintenance guy, and I've set it as I've logged in as the maintenance guy with read only. You can tell I've only got read only because everything is grayed out. And the problem that I found, I can go online. So I can go online. I have changed a block while I was logged on as a different user. So in this instance, it is there, and it won't let me download that block, even though I've got, say, the maintenance user. It won't let you download a changed block. I've tried to, the download is not becoming access to it, and the reason is that it wants to compile the project to download that block, and it won't let me compile it, so it won't let me download it. So yeah, if you're logged in as a maintenance user, you can't download a change block. I can't actually, as a maintenance user, change a block anyway, because I have read-only access. I can still go into a block, and I can go online to a block, so I can do diagnostics. I just can't make any changes to the blocks. So I can still get in here, and I can still go online, still do diagnostics, but I can't make any changes, and I can't download a change block. But I would not, as a maintenance, as a person who's only got read only, I wouldn't be able to change the block anyway, because everything is grayed out and I can't get to it. So those were those two questions. So with that, I'll end the recording. Me and Ben will be here if anybody has got any further questions. We're quite happy to take them.